So when we have a small number of dimensions in our mathematical problem, we can make use of the graphical methods to solve sets of simultaneous equations. And now when I mean small dimensions, I'm talking, say, less than 3. So graphical methods are fairly self-explanatory. The basic idea behind it is that you can plot two equations on Cartesian coordinates with the one axis corresponding to x1 and the other x2, for example, if we were dealing with a two-dimensional problem. So, and because we're dealing with linear equations, these will show up as straight lines on our Cartesian coordinates. So for example, if we have the following set of linear equations, that is a11 x1 plus a12 x2 being equal to some constant b1, and a21 x1 plus a22 x2 being equal to another constant b2, we can arrange these equations. So we can take equation 1 and rearrange it in terms of x2 being equal to negative a11 over a12 x1 plus b1 over a12, and we can do the same for our second equation, that is x2 being equal to negative a21 divided by a22 plus b2 over a22. Can you see how this is similar to our normal straight line equation where we have our slope term and our intercept? And the intersection between these two equations or lines is where our solution will lie. Okay. So in 3 dimensions, what happens? Well, in 3 dimensions, it gets a little bit more complicated. And obviously, when you get to higher dimensions, the whole method itself breaks down. But it is useful in visualizing problems that may initially be complex. Let's just get back to the 3-dimensional problem. So in 3 dimensions, effectively, we'll have 3 planes, and where the point at which they intersect is going to be where our solution will lie. So we may have a set of planes. Remember, we're dealing with things in 3 dimensions here. So I'm just going to draw it like this. Let's add another dimension. Now you can see where these 2 planes intersect. And that's obviously representing a number of solutions along the green line. But if we then add a 3rd plane, effectively what we're doing is providing an intersection point. Okay, and it's at this point that the solution to our equation will be known. Okay, so some useful thoughts behind the graphical method is that if we plot our equations and we end up with a parallel set of lines, we know there's not going to be any solution. If the plot shows the 2 lines sitting on top of each other, then we know we're going to have an infinite number of solutions. And something which is also quite interesting is that we can actually have an ill-conditioned system. That is, it's very difficult to know where the actual solution lies. And because the two lines appear quite close together, and this is where where it becomes difficult to actually figure out the solution.